Hello, math students, and welcome back to our module called Linear Equations. This is lesson 2, and it is called Linear and Nonlinear Expressions in X. Our goal for today we will learn the properties for identifying an expression as linear or nonlinear. The question that I want you to think about in this lesson is, how do you know if an expression is linear or nonlinear? All right, so we have been talking about expressions and equations, remembering that the difference between an expression and equation is that an expression is a math sentence that cannot be solved, and an equation is a math sentence that can be solved. And the reason that we know this is because an equation is set to equal something. And expressions just are math sentences that describe what is available, but there's no solution. So with that knowledge, what we have to do is we have to look at some of the expressions that we are given in this lesson, and we have to decide if they are linear or not linear, and you, by the end of the lesson, will be able to figure out the difference between the two. All right, so things to know. An equation is built by having one expression that is equal to another expression. So for example, we have 5x to the power of 2 is equal to x plus 3. So this little component right here is considered an expression because it is a math sentence that is giving us information about a number. And then this is also considered an expression because it's a math sentence that is giving us information about the number. And then when you set them up to equal each other, they turn into an equation. So an expression equals an expression. That is also known as an equation, okay? But each individual piece is considered an expression. An expression in X is a math sentence that involves operations and variables. So this is an expression in X because we have a coefficient, we have a variable, and both of those are raised to the power of 2. So we have a coefficient, we have a variable, and both of those are raised to the power of 2, so that's considered an expression. Then we have a variable plus a constant, and this is also known as an expression in X because we have a variable plus a constant. And so we have two different examples of expressions in X because the variable that's involved is an X. Now you can have expressions in Y's, you can have expressions in T's and R's and L's and N's. It doesn't really matter that it's called an expression in X. It's only identifying the variable that you're using as X. So it's an expression that has the variable of X. Understand what makes an expression and what makes an equation is understanding what makes an expression and what makes an equation is very important to identifying linear expressions and nonlinear expressions. So knowing the difference between equations and expressions will help you understand whether the expression is linear or nonlinear. Okay, so what I would like you to do now is I have a practice that I want you to take a look at, and it says practice time. There are expressions listed in the table below. I would like you to sort them into two different groups. So when you're looking at these examples, the two different groups that I would like you to figure out is your choice. We're calling one of them group A, and we're calling the other one group B. However, when you identify what those two groups are, you have to be consistent. So you have to figure out what would be a good group A and what would be a good group B. So if we start looking, we have the expression. Notice all of these, if you look at all of them throughout the table, are expressions. None of them are equations because none of them have that solution capability because none of them are equal to anything. So these are all expressions. This one says 5x plus 3. So we have the variable x being multiplied by the coefficient of 5 and then added to 3. So 5x plus 3. Now we have the variable, however that variable is raised to the power of 2. Then it's being multiplied by the coefficient of 4, and then we're supposed to subtract 9. Okay. Now we have x plus 2 is the quantity, and it's being multiplied by a factor of 11. So this is kind of like factored form, if you remember. So we're supposed to distribute that out. Then we have negative 8x plus 7/9 minus 3. And so we have the variable times the coefficient of -8, then we're adding it to the fraction of 7/9, and then we're subtracting 3. Okay, then we have 31/100 times the variable x, so that would be the coefficient, plus 7 minus 4 2/10, which is the coefficient to the variable x. Now we have 6 minus x multiplied by a -1 plus 15 minus 9x. Then we have 9 minus x squared, so that's taking the variable and squaring it, and then once we've done that, we subtract that from 9. Now we have x divided by 2, but it's also being raised to the power of 3, and then we're adding 1. Then we have 7 plus x to the -4 plus 3, the coefficient, times the variable x. So we've got a lot going on, and I'm kind of at a loss for what kind of groups we should be sorting. So let's back up and let's only focus on the variables in each situation. If I say focus on the variables of each situation, this just has an x. Yes, it's being multiplied by a coefficient, but there's no exponent. So that's one idea. This is x, which is the same variable, but the difference between this one and this one is that this one, yes, it's being multiplied by a coefficient, but it's also being raised to the power of 2, so it does have an exponent. This one is just x being added to 2, and then the whole thing is supposed to be multiplied by 11. This one is just x being multiplied by a -8. This one is an x being multiplied by 31/100. This one is just x, which is being multiplied by a -4 2/10. This one is just x. It's being subtracted from 6 and then multiplied by a negative. This one is just x being multiplied by a -9 coefficient. This one is x squared. So I notice a difference there. And x squared is being subtracted from 9. Then we have x being divided by 2, but then it's being raised to the power of 3. So the whole thing is being raised to a power of 3. And then we have x being raised to a negative power of 4. And then we also have x raised to nothing. So the biggest thing that I could see as a possible grouping choice would be what is happening to the x. And so maybe if we can come to agreement, we could say that group A would be the variable is raised to a power of 1 or less. Okay, so that's interesting. And then group B would be, let's say, the variable is raised to a power that is greater than 1. Okay, so I think those are the only two groups that I can see if we are grouping these into two separate groups that will actually work for putting them into the list. So let's go back and let's say the variable is raised to a power of 1 or less. So if we're looking at this one, is the x being raised to the power of 1? The answer is yes. So I'm going to color it with the green color. This one, it says that the x is being raised to a power of 2, so that would not work for this one. This one, it says the x is being raised to a power of 1. Remember, when it doesn't list the exponent, then our automatic exponent is 1. This one says that the x is being raised to a power of 1, so we can go ahead and do this one, right? This one says that the x is being raised to a power of 1. The x is being raised to a power of 1, so those two will sit there. This one, the x is being raised to a power of 1. The x is being raised to a power of 1. Okay. This one, the x is being raised to a power of 2, so that won't work. The x is being divided by 2 and then raised to a power of 3, so that one won't work. And then this one right here is kind of interesting because it says that it's being raised to a -4, which would be less than 1. However, when we have negative exponents, we know that what they really are is it would be 1x to the 4th, So 1 divided by x to the 4th is still a power greater than 1, and so I would think that one can't count either. All right, so we have two different groups now. All right, so this one has a power greater than 1. This one has a power greater than 1. This one has a power greater than 1. And then if we're not working with negative exponents, then we know that this is 1x to the power of 4, which is greater than 1. And so those are the two different groups that we were able to sort these into, okay? And now what we have to do, if we go back to our goal, it says today we will learn the properties for identifying an expression as linear or nonlinear, and we have two different groups. So having said that, what you now need to understand is that you have now figured out what is the difference between linear and nonlinear. The difference between linear and nonlinear is that linear means that it will make one straight line when you graph it. Nonlinear means that you're going to have not a straight line. And what makes you not have a straight line is when the variable is raised to a power that is greater than 1. And so this, all of the oranges, are known as nonlinear, okay? And all of the greens are known as linear. So when we graph these, you actually are going to learn how to graph all of the green ones, okay? All of the green ones you are going to learn how to graph in Math 8. All of the orange ones, you are going to learn, one of the first things that you learn in algebra is how to graph nonlinear expressions. And the reason why you will learn that in algebra is because you have to learn what it means to square something or cube something or a power greater than that and what it gets displayed as a graph. So that is an algebra standard. So now you know the difference between linear. Linear means that the variable is raised to a power of 1 or less, okay? And when I say less, I want to clearly define it's usually 1 or less, which would be equal to 0. Okay, so that's what we have to keep in mind in that. So those are linear. And then nonlinear is a variable that is raised to a power that is greater than 1. Okay, so on the back side, I would now like you to come up with a definition of what a linear expression is and a nonlinear expression is. That's your job to finish up this lesson. Come up with a definition for a linear expression and a nonlinear expression. Okay? So our goal, today we will learn the properties for identifying an expression as linear or nonlinear. How do you know if an expression is linear or nonlinear? If it's linear, then your variable has an exponent of 1 or 0. And if it's nonlinear, then your variable has If it's linear, then your variable has an exponent. Did I say that right? Yeah, an exponent of 0 or 1. If it's nonlinear, then it has an exponent that is greater than 1. Okay, that's how you tell the difference between the two. All right, kiddos, that's all I have for you. Make sure you write those definitions of linear expressions and nonlinear expressions. See you later. Bye.